Hello, welcome to another pre-AMC video on the San Antonio Math Included YouTube channel. I'm Olivia M, and let's get started. We want to find the ratio of the volume to the surface area of this shape. Okay, and we know they're made out of unit cubes, specifically 7 unit cubes. So that means there was one in the middle too. So how would we find, let's start with the volume. So volume, we could just find the volume of each individual cube and then add them together to find the total volume of the entire shape. So let's figure that out. So the volume of one cube, it's a 1 by 1 by 1 cube. Remember volume, that's going to equal length times width times height. Length is 1, width is 1, height is 1. So volume of one cube is 1, and there's 7 cubes. So the entire volume is 7. Right? So the volume of the entire shape, 7. Okay, what about the surface area? The surface area is just going to be us adding up all of the sides that are visible. So every side that you can see, that's going to add 1 to the surface area. Okay, well, let's look at each block individually. What about that top block? Well, for that top block, you can see its top face, front face, other side face, so that's 3 faces so far. You could also see, I'm going to make it a transparent box. This face right here, this sideways face, because that is not being covered by anything, so what's here on the left, that would be visible, and the back face as well, right here, this back face. It's also not being covered. The only face that's being covered is the bottom. So 5 faces are visible on that top cube. And the same thing with the front. This front cube right here, the only thing that's being covered up is the back face, the one that's touching all the other cubes. So 5 faces are visible on that front cube also. And as it turns out, all of these cubes that we can see, 1, 2, 3, 4, 5, 6, they all have 5 faces that would be showing. The only thing that's not showing is the one cube in the middle. You can't see any of it. So that means we have 6 unit cubes with surface area 5. So we've got 6 times 5, that's 30 for the surface area of the entire shape, right? Because each of those 6 cubes is giving us an extra 5 to the surface area. So our ratio of volume to surface area, that's 7 to 30. Answer choice D. All right. We've got Mrs. Osborne asks each student in her class to draw a rectangle with integer side length and a perimeter of 50. All of her students calculate the area of the rectangle they drew. What is the difference between the largest and smallest possible areas of the rectangle? All right, let's see what we could do. So I'm going to look at our extremes. So what's the longest rectangle we could have? Well, we want a perimeter of 50, so we could have 2 really small sides, so a 1 and a 1, and then the other 2 sides would have to add up to 48. So that'd be 24 and 24. So this is one of our extremes, right? It's got one really long side and one really short side. So 24 plus 24 plus 1 plus 1 is 50, and this rectangle has area 24. Okay, what if we had a more balanced rectangle? What if all of the sides were equal? Well, we'd have 50, well, not equal because we can't do equal, but as close to equal as possible. Right? So we have 50 divided by 4. It's not going to go in evenly, but that's okay. 1. So that's 12 and a half. So we can have 2 side lengths of 12 and 2 side lengths of 13. Right? And that'll add up to 50. This rectangle has area 13 times 12. That is 156. So it seems like when we have a rectangle that's very unbalanced, like our first one, we get a small side, and then our most balanced rectangle has the biggest side, right? 156 to 24. So what's the difference between the largest and smallest possible areas? Well, our largest is 156, our smallest is 24, so this difference is 132. Answer choice D. Okay, we've got 2 circles that share the same center, and they have radius 10 meters and 20 meters. An aardvark runs along the path shown, starting at A and ending at K. How many meters does the aardvark run? Okay, so we've got two circles. We've got a circle with the big radius, the bigger circle, that has radius 20, and then the smaller circle with radius 10. Okay, we see that the aardvark, it's going to start out by running along a quarter of the larger circle, right? So this part here, that's going to be a quarter of the larger circle, and more specifically, a quarter of its circumference, right? The circumference is basically like the perimeter, but for a circle, right? So it's going to be that quarter part. So our circumference, remember, is 2 times the radius times pi. In this case, we're using our big radius, so 2 times big radius times pi. That's 40 pi. But again, we're only going across a quarter of the circle, so we divide this by 4. And that's this length here, that's 10 pi. Okay, what about this? That second part is the part that's the big radius minus the little radius, right? We're not going across the little radius for that, it's just the big radius. So the big radius minus the little radius, that's a distance of 10 right there. That's just 10. Okay. Now we've got another quarter radius of the small circle. So, not a quarter radius, a quarter circumference. So, our circumference is 2 times, this time little radius times pi. Our little radius is 10, so we've got 20 pi. And remember, we're only using a quarter of this, so we'll divide it by 4, right? Because we're only going around a fourth of the circle. That's 5 pi. So this distance here is 5 pi. Okay? Then we go along this length. That length is 2 times the radius of the little circle, right? We got one radius and then a second radius. So that's 10 and 10, so that length is 20. Okay? And then we've got another quarter of the small circle, which we already found out is 5 pi. And lastly, another length here, which we found out is 10, right? That's the same as this length here. So adding that all up, we've got 10 plus 5 pi plus 5 pi, that's 20 pi, plus 20 plus 10 plus 10, that's 40. So the aardvark ran 20 pi plus 40. Okay, we've got 8 points spaced on an interval, 1 unit around a 2x2 square as shown. 2 of the 8 points are chosen at random. What is the probability that the points are 1 unit apart? Okay. So it's a 2x2 square, so that means this length is 2, but the length from one dot to the one next to it, that's going to be a distance of 1. So what's the probability that if I pick a point, that the next point I pick would be 1 unit away from it? Well, let's say I picked this point. How many points are 1 unit away from it? Well, that'd be this point here and this point here. There's 2 points that are 1 unit away from it out of a total of 1, 2, 3, 4, 5, 6, 7 other points, right? So if I pick that middle dot, there'd be 2 out of 7 ways to get another point that's 1 unit away. The thing about that is that this is the same whether I pick that middle point there or the middle one here or here or here, right? They're all the same because the square makes them the same. We could just rotate it and have the same result. So if I pick this middle square, we'd have a 2 in 7 chance of the next dot we pick meeting that condition. Okay? Now, what if we picked a corner square? Oh, ignore that. What if we picked a corner square? Would it be any different? Well, if I picked a corner square, there's still there's still 2 dots that I could pick that would meet our condition. So no matter what first dot you pick, there will be 2 out of 7 dots that you could pick after that would be 1 unit away from it. So our answer is 2 over 7. There's a 2 in 7 chance. Answer choice B. Okay, because 2/3 of the boys passed and 3/4 of the girls passed, we need a number that's divisible by both 3 and 4. Okay? So let's try that out. Well, we could have 3 boys, 6 boys, 9 boys, on and on. We could have 4 girls, 8 girls, 12 girls, and on and on. So if we have 3 girls, or 3 boys, that means 2 of them pass the test. If we have 6 boys, we need 2/3 of that. That'd be 4 boys pass the test. 9 boys, we need 2/3 of that. 6 boys pass the test. Okay, what about 4 girls? If there are 4 girls in the class, 3 would have passed the test. 8 girls would have meant 6 girls passing the test. And look, now we've gotten somewhere. We have here where there's 6 boys who pass the test, and here where there's 6 girls who pass the test. And so that's an equal number of boys and girls, right? So that means we could have 9 boys and 8 girls, with 6 boys passing the test and 6 girls passing the test, which is what we wanted. So how many students is that total? If there's 9 boys and 8 girls, 9 plus 8 means 17 students. Okay. Jerry cuts a wedge from a 6 centimeter cylinder of bologna, as shown by the dashed curve. Which answer choice is the closest to the volume of his wedge in cubic centimeters? The cylinder is the same thing, but this time our base is a circle. So we need the area of our circle. So we've got height times our area of the circle at the bottom. Area of a circle, remember, is radius squared times pi. That's going to be the volume of a cylinder. So here, with our bologna, we've got 6 centimeters being straight up and down part. In this case, the cylinder's on its side, but it's still going to count as our height. So we've got 6 times, and now we need the radius of the circle part of the bologna. Well, we see the diameter is 8 centimeters, that's all the way across. We want the length from halfway through the bologna, though. We want this. So half of 8, that would be 4 centimeters squared times pi. Okay? 4 times 4 is 16. 6 times 16 is 96. And then we multiply that by pi. 96 times pi, we'll say pi is pretty close to 3. Okay, like we said, 6 times 4 squared times pi, that's 96 pi. But Jerry cuts this right here. He's cutting half of that bologna. It's slantways, but it's still half of the bologna. So Jerry only wants half of it. So we'll divide our 96 pi by 2. 96 divided by 2 is 48 pi. Okay. Now we want 48 pi. Well, pi is going to be pretty close to 3, so we'll multiply by 3. 48 times 3 is 144. Remember, pi is a little more than 3, so we're going to want to go up from there. So our next closest is C, 151. And you can multiply it by 3.14 if you want more accuracy. I don't recommend going above, like using more than 2 decimal places, because it gets pretty tedious if you do. There's more room for error. Okay. For how many positive integer values of n are both n over 3 and 3n 3-digit whole numbers? So we want a number that can be divided by 3 and still be 3 digits, and can be multiplied by 3 and still be 3 digits. And we want to know how many of those there are. Let's see. What's the smallest 3-digit number? That would be 100, right? You could multiply that by 3 and you'd get 300, and then multiply that by 3 again and you'd get 900. So in that case, n equals 300, right? You can divide it by 3 and get a 3-digit number, and multiply it by 3 and get a 3-digit number. So you can do that for n equals 300. That would be our smallest, right? Because any smaller of a number, and then you divide it by 3 and you get a number less than 100, and less than 100 would mean it's not a perfect square. So that doesn't work. Okay, what about our biggest? Well, our biggest would only work if you could multiply it by 3 and still get a 3-digit whole number. So what's our biggest 3-digit whole number? That's 999, right? Biggest 3-digit whole number. We could divide that by 3. We would get 333. And then our next one, you would get 111. So our biggest one would be n equals 333. Right? We can't get any bigger, because if we got any bigger, we would multiply by 3 and get a 4-digit number instead of a 3-digit number. So that doesn't work. So n equals 333. Now, we have numbers between 300 and 333, but it can only be numbers that are multiples of 3 because they need to be able to be divided by 3, right? 301, if you divide it by 3, it's not going to be a whole number, right? 301 divided by 3 doesn't go in evenly. So after 300, we'd have 303, then 306, right? We're going up by 3, 309, 12, 15, 18, 21, 24, 27, 30, and 33. And now we're at our max, right? 333. So how many numbers is that total? 3, 6, 9, 10, 11, 12. Answer choice A. Okay, we got square ABCE. AF equals 2FE. We've got this length is half of it, so that's double. And CD equals 2 times DE. So this and this doubled. We've got, what is the ratio of the area of BFD to the area of the square ABCE? Okay. Well, let's see. We want something that's divisible by 3, right? I'll just set it B3. Let's say our square has length 3. Well, then we've got 3, and then here it's split, right? AF is twice FE, so FE would be 1, and AF would be 2, right? That adds up to 3, and 2 is double 1. The same would be true over here. We'd have 1 and 2. Okay. Then we could find the area of square ABCE, right? ABCE, that's just going to be 3 by 3, right? Because it's 3 by 3 square. So that's 9. And then we can find the area of this triangle, BFD, by subtracting the area of the rest of the square, right? Taking away what's on the outside of the triangle. So we've got a 2 by 3 triangle, right? FAB. We've got a 2 by 3 triangle that has area 2 times 3 divided by 2. Remember, area of a triangle, base times height divided by 2. That is 2 times 3 over 2 is 3. The same is true for BCD, right? 2 by 3 also has area 3. And then FED, this triangle right here, has area base times height, 1 times 1 over 2. 1 times 1 over 2, that has area 1/2. So our total area outside the triangle is 3 plus 3 plus 1/2. That's 6.5. Okay, so the area inside the triangle, if that's everything that's outside the triangle, we can find what's inside the triangle by doing 9 minus 6.5. That's 2.5. So our ratio to BFD to ABCE is 2.5, 2.5 to 9. Our ratio needs to be in whole numbers, so we'll multiply by 2, right? 2.5 times 2 will be 5 to 18 is our ratio. Answer choice C. Okay, we've got 10 tiles numbered 1 through 10. They're turned face down. 1 tile is turned up at random, and a die is rolled. What is the probability that the product of the numbers on the tile and the die will be a square? Okay, so we've got 10 tiles, and then a dice which has 6 faces, right? So we got the probability that the product on the tile and the die will be a square. So let's run through the cases. So either we've got 2 squares or 2 non-squares that are the same, right? So if we had the tile is 3 and the dice is 3, that'd be 3 times 3, we'd get a square, right? So if the two are the same, we get a square. So let's do those cases. That's 1 and a 1, 2 and a 2, 3 and a 3, 4 and a 4, 5 and a 5, 6 and a 6. Okay? The other way we could get a square is if we started with 2 squares, right? So if we start with 2 squares, then we'd have another way to do it, right? So that'd be like having a 1 and a 4, right? 1 and a 4. Or a 4 and a 1, right? Because they're different. It's a 1 on the tile and a 4 on the dice versus a 4 on the dice and a 1 on the tile. Okay, we could also have a 1 and a 9, right? But we couldn't have a 9 on the dice because that's not possible. And also a 4 and a 9. So those are other ways. And remember, how many combinations are there in total? There's 60, right? There's 6 choices for the dice times 10 choices for the tile. So that's out of 60. And right now we've counted 6, 7, 8, 9, 10 out of 60. Okay, are there any more? Are we missing any? Okay, well, there is one, and that one's the trickiest one to spot. That would be if we had a 2 on the dice and an 8 on the tile, right? 2 times 8, that would make 16. Right, so that's another way to get a square, is the 2 and the 8. So that's plus 1, that's 11 out of 60 ways to get a product that's a square. Answer choice C. Ooh. It's kind of an interesting art design. So Maggie's winning art design. The smallest circle has radius 2, and each successive radius increases by 2 inches. So what percent of the design is black? Okay, well, we've got that original circle. That's got radius 2. So that area of this circle here is 2 times 2 is 4. So 4 pi for that circle. And then our white circle after that, that has radius that's increased by 2 inches. So instead of 2, it's 4. So now we've got 16 pi for that, but we have to subtract this circle, right, because it takes up space. So that's 16 minus 4, so that's 12 pi. So 4 and pi and then 12 pi. And now we've got another increase in 2, so this time the radius is 6. So 6 times 6 is 36. But remember, we have to subtract the 16 pi. That's all of this area, right? So 36 minus 16, that's 20 pi. And now we can see a pattern. This is always increasing by 8 pi, right? We get from 4 pi to 12 pi, 12 pi to 20 pi, and that's through an increase of 8. Okay, so that's helpful. So our black area is going to be the 4 pi plus 8, so plus the 20 pi. Plus we've got another 8 added, so that's 28 pi. Okay, so that's a total of how much? 28 plus 20 plus 4, that's 52 pi. Out of how much? So 52 pi is the area that's black. Now we need the area of the entire circle. So we've got a radius of 2, radius of 4, 8, 6, 8, 10, 12. That's a radius of 12. 12 times 12 is 144 pi. So 52 out of 144 pi is black. Okay, can we simplify that? Well, we can cancel out the pi's. We can divide 52 and 144 by 2, right? So that'd be 26 over 72. You can divide that again. That's 13 over 36. Okay, so what is that as a percent? 13 over 36. Well, we want 13 over 36 as a percent. We can cross multiply, right? We can do 13 times 100. That's 13 with 2 zeros. And then divide that by 36. divided by 36, we get 4. 36 times 4, 100. All right, Bridget bought a bag of apples at the grocery store. Half of the apples are given to Anne, and then she gave Cassie 3 apples, keeping 4 apples for herself. How many apples did Bridget buy? Okay, half of them went to Anne, so Anne got a half. She gave Casey 3, so Casey got 3. And then she kept 4 to herself. So after she gave away half, she had half left, right? And out of those that half, she gave 3 to Casey and then kept the other 4. So half of those apples were the 3 she gave to Casey plus the 4 she kept for herself. That's a total of 3 plus 4 is 7 is half of her apples. So if she had 7 is half, then doubling it will give us all of it. So 7 times 2 is 14 apples that Bridget bought. Then we have, on average, every 4 sports cars sold at the local car dealership. On average, for every 4 sports cars is 7 sedans, and that the dealership predicts that it will sell 28 sports cars next month. How many sedans does it expect to sell? So we've got 4 sport cars to 7 sedans. Okay, 4 to 7 is our ratio. So we want to know if the sports cars are 28, how many sedans are we going to get? So 4 to 28, how do we get from 4 to 28? We'll multiply by 7, right? 4 times 7 makes 28. So we can do the same for the sedans, right? We do 7 times 7. That will be 49 sedans. So for 28 sports cars, we get 49 sedans, which is answer choice D. Okay, graph shows the constant rate at which Susanna rides her bike. She rides a total of half an hour at the same speed. How many miles have you ridden? Okay, so we see that in 5 minutes, she goes 1 mile. 10 minutes, she goes 2 miles. 3 minutes, she goes 15 miles. 4 minutes, she goes 20 miles. So we can keep increasing, right? This increases by 5 minutes. So in 25 minutes, she'll have gone another mile, right? She goes 1 mile every 5 minutes. So another 5 minutes, another mile. So she'll have gone 5 miles in 25 minutes. Then we increase again. So in half an hour, that's 30 minutes. She'll have gone another mile. That's 6 miles in 30 minutes. Answer choice C. Okay. 5 pieces shown on the right can be arranged to form 4 of the 5 figures below. Which figure can't be formed? So we know we have one that's going to be of length 5. And that one's always the trickiest to place. So for B, we know we can't use number 5, right? Because there's no 5 blocks in a row. So B can't have 5. Is it still possible to make B? Well, let's see. We could put the 4 like this, the 3 like this, and the 2 like this. But that means we only have 1 left over. So if there's no room for the 5 in B, and we can't form it without the 5, then B is impossible, right? The other ones, the 5 is accounted for, and then the 4, and the 3, and the 2, and the 1. 5, 4, 2, 3, 1. 5, 4, 3, 2, 1. C. 5, 4, 3, 2, 1. Yep, B doesn't have room for the 5, so you can't do it with the B. Okay, we've got a sequence with numbers. Starts with 1, 2, 3. Fourth number of the sequence is the sum of the previous 3 numbers. So we start 1, 2, 3. Then you add those to get the next term, which is 6. Then we would add 2, 3, 6 to get the next one. 2 plus 3 plus 6 is 11, and then we keep going. Okay, every number after the 4th is the sum of the previous 3. What is the 8th number? Let's see. We got first, second, third, fourth, fifth. We might as well keep going. 3 plus 6 plus 11 gets us to 20. 6 plus 11 plus 20, we get 37. 11 plus 20 plus 37 gets 68. Are we at 8? We're at 8. 68 is our 8th number. Answer choice D. Okay, we got Steve's swimming pool. Will hold 24,000 gallons of water. It will be filled by 4 hoses, each of which supplies 2.5 gallons per minute. How many hours will it take to fill Steve's pool? So in total, we've got 4 hoses. So in 1 minute, they'll do 2.5 plus 2.5 plus 2.5 plus 2.5. That's 10 gallons a minute per minute. So in an hour, that's 60 minutes. They'll have done 10 times 60. That's 600 gallons in an hour. And we want to know how long it takes to get to 24,000 gallons. So we have 24,000 divided by 600. That's the same as 240 divided by 6. That would take 40 hours. Right? Answer choice A. Got a plot of land. Lies between Aspen Road, Brown Road, and a railroad. Main streets run east and west, and railroads run north and south. Okay. The numbers in the diagram indicate distance in miles. And we want to know the width of the railroad track can be ignored. How many square miles are in the plot of land ACD? So we got ACD. Okay. Well, we notice, here's ACD, we've got a triangle, right? And how do we find the area of this triangle? Well, we want to find the base times the height. Here's the base, here's the height. And this may seem a little tricky because the height isn't actually inside the triangle, but that's okay. It doesn't need to be. We're just looking for the height from the tallest point to the bottom point. Okay, so what's our height? Well, we can see here that height is 3, right? To get from the top to bottom. So here's our height of 3. And then from Aspen to Brown, we see that this distance is also 3. So here's 3. So what's the area of that triangle? Base 3 times height 3 divided by 2. Remember, area of a triangle, base times height over 2 is 9 over 2. That's 4.5. Answer choice C. Okay, the length of the rectangle is increased by 10%, and the width is decreased by 10%. What percent of the old area is the new area? All right, let's make a rectangle. Let's call it 10 by 10. 10 by 10 is easy, right? What's the area of the old rectangle? So when it's 10 by 10, that area is 100. Okay? And when we have the new area, now one length is going to be increased by 10%. So added 10% to 10. 10% of 10 is 1. So increased by 1, we get 11. And the other side is decreased by 10%. So minus 1. That's 9. So our new rectangle is 11 times 9. That's 99. Okay, our old rectangle was 100. New is 99. What percent of 100 is 99? So 99, that's 99% of 100. Right? Answer choice B. And see, this problem can be made easier by just plugging in values that are easy to work with. Right? When I think percents, in my head I go, I'd rather work with 100%. 100% makes things, simpler. It's nicer. If I had some 48%, that wouldn't be as nice to work with. So use the problem, find values for your problems that'll make it the easiest to go through. It's my advice. And it's okay if you don't always get it right on the first try. We want to construct a square on one side of an equilateral triangle. On one non-adjacent side of the square, construct a regular pentagon as shown. On a non-adjacent side of the pentagon, construct a hexagon. So that'd be a 6-sided shape. Continue to construct regular polygons in the same way until you construct an octagon. How many sides does the resulting polygon have? So let's see. First, we start with a triangle, right? That had 3 sides. Then we added a square, right? So suddenly we had a triangle, but we lost a side and we got a square, right? That's what it looked like. So then we had 2 sides plus the 3 square sides, we had 5. Okay, then we added a pentagon. So we had our shape, we lost a side for the square, and we made a pentagon. So how many sides does that have? 1, 2, 3, 4, 5, 6, 7, 8. So now we're at 8. Okay, then we would add a hexagon. A hexagon. Oof, this is getting complicated to draw. I'm not an artist. Hexagon. Let's go with that. Pretend that's not there. How many shapes is that? Or how many sides is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we went from 3 to 5 to 8 to 12. Right? So that's with 3 sides, we got a 3. With the square added, so that's now a square, pentagon, 5, hexagon, 6. So we went from 3 to 5, we increased by 2, then we increased by 3, then we increased by 4. So it seems like every time we add a shape, we'll increase the number of sides that we increase by 1. So increase by 2, then increase by 3, then increase by 4. Next, we'll increase by 5. So when you add in the heptagon, the 7-sided shape, you'll add another 5. You'll add in 5 sides. So 12 plus 5 would be 17. Okay, now we'll add in the octagon, the 8-sided shape. We added 5 last time, now we'll add 6. 17 plus 6, 23. See, and the reason we were able to find it out without drawing it, because that would be horrible to draw, would be because we found a pattern, right? So looking for patterns not only from in 3, 5, and 8, but also in how they change. So they change by 2, then 3, then 4. That's a clearer pattern than 3, 5, 8. Okay. And a checkerboard of 64 squares. What is the probability that a randomly chosen unit square does not touch the outer edge of the board? So how many unit squares don't touch the outer edge of the board? That would be these ones, right? The ones that don't touch the outer edge of the board. How many are there? Well, it's a 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6. So that's a 6 by 6 square. So that's 36 out of, we know that there's 64. Do not touch the outer edge. Can we simplify that? 36 over 64, those numbers are both divisible by 2. We can simplify, divide by 2. 18 over 32. We can simplify again, divide it by 2. 9 over 16. That's answer choice D. Okay, the Amico Middle School bookstore sells pencils costing a whole number of cents. Some 7th graders each bought a pencil, paying a total of $1.43. Some of the 36th graders each bought a pencil, and they paid a total of $1.95. How many more 6th graders than 7th graders bought a pencil? Okay. So this pencil, the total cost of a pencil needs to be divisible. It needs to be a multiple of 143 and a multiple of 195. So what are the factors of 143? Right? Because it needs to be divisible by that for multiple to buy it. Well, we've got 1 times 143. It's not divisible by 2, right? Is 143 divisible by 3? No, it's not. Not divisible by 4. Is it divisible by 5? No. Divisible by 7? No. Not 8, not 9, not 10. It is divisible by 11, though. So 11 times what makes 143? Be 13. And those are all of the factors, right? So either the pencils cost 1 cent, 143 cents, 11 cents, or 13 cents. Okay, what about 195? What are the factors of 195? We got 1 times 195 cents. We've got not 2. We've got 3 times, divided by 3. 3 times 65. Not 4, it's divisible by 5. 5 times 39. Not 6. Not 7. Not 8. Is it divisible by 9? No. not divisible by 10 or 11 or 12, but it is divisible by 13. So 13 times 1 times 15. All right, so what factors do 143 and 195 have in common? Well, 1. They both have 1 in common, and they both have 13 in common, right? And we know the pencils can't cost 1 cent, because if it costs 1 cent, then we need 195 6th graders to buy them, but only 30 6th graders bought a pencil, so they can't be 1 cent. But it could be 13 cents, right? Because then 15 6th graders could buy a 13-cent pencil, and they'd pay a total of $1.95. So, if the pencils cost 13 cents, 11 7th graders bought them, 15 6th graders bought them. How many more 6th graders than 7th graders? That's 15 minus 11. Answer choice D, 4. 15 minus 4 is 11. Okay, we've got 2 spinners shown. They spun once, and each lands on one of the numbered sectors. What is the probability that the sum of the numbers on the 2 sectors is prime? Okay, so what are our prime numbers? Okay, 2, 3, 5, 7. Next is 11, and that's our biggest possible one, right? Because our biggest numbers are 5 and 6, so we can't get anything bigger than 11. So is it possible to get a 2? No, it's not, right? Because the best we could do is a 1 and a 2, and that gives us a 3. So we could spin a 1 and a 2. That would get us a 3. Could we get a 5? Yep. We could do a 3 and a 2. 3 and a 2. Or a 1 and a 4. So that's 2 ways to get a 5. So there's 1 way for a 3, 2 ways to get a 5. How about a 7? You could do a 1 and a 6. You could do a 3 and a 4 and a 2 and a 5. That's 3 ways to do that. And with the 11, we could do just a 5 and a 6. That's the only way. So that's 1 way. So that's a total of 1 plus 3 plus 2 plus 1. 7 total prime sums. Like, that's the 7 ways to get a prime number. Okay, how many combinations are there in total? Well, there's 3 numbers here and 3 numbers there. 3 times 3 makes 9 possible ways to spin the spinners, right? 3 and 1